So Rule 1, control devices such as switches, push button relay contacts, and sensor contacts must be played between L1 and the rung's load. Y'all understand that? Any questions on that one? Output devices such as relay coils, lights, small motors, and solenoids must be placed between the control devices and L2. One and only one output can be placed in a rung line. A rung is an electrical circuit that runs between L1 and L2 that consists of one or more lines, right? Magnetic motor starter overloads contacts are the only thing that's allowed between the motor starter coil and L2. All of the rung loads must connect directly to L2. You understand that? Yes, no? Okay. Control devices can be connected in series, parallel, or series parallel. The connection of control devices does not determine if the circuit is series parallel or series parallel. That's determined by the loads, right? Not by the switches and the contacts. We can connect those anyway depending on how we want to control the rung. Multi-rung output devices cannot be connected in series. However, multiple output devices can be connected in parallel in a different line within the rung, right? You understand that? Only one output device can be connected in a rung line. The rule is one or more output on a rung, but only one output per line. There are no series or series parallel circuits in relay logic. Everybody understand that one? Are we okay? Control devices such as switches, relay, and sensors with single contacts can only be used once in a relay logic ladder diagram. Control devices that have multiple contacts can be represented multiple times in the relay logic diagram, but the same contact can only be used once. In other words, the same control device contact cannot be used multiple times. Do y'all understand that? Yes? Okay. Each contact controlled by a relay must be given the same name as the relay that controls the contact. Everybody okay there? An output device can only be represented once in a diagram. So you can't call a coil M1 and then somewhere else use the same name, right? M1. You can only have that contact. That coil can only be once in a diagram. In one line, right? All control devices and output device symbols must be placed horizontally. So we don't have any vertical. So basically the only thing that runs verticals are connection lines, right? Everybody understand that? All control devices and output device symbols must be placed horizontally. Signals in a relay logic diagram must flow from L1 to L2. Signal flow must never flow back toward L1. Y'all understand that? We okay? Diagrams should be numbered and commented correctly, unlike PLC logic diagrams. Horizontal lines are numbered and not rung. So I should have marked that off, but we also use this in PLCs. So in PLCs, we number rungs because every time you insert a new circuit, it gives it a rung number. In motor controls, we number lines. That makes sense. And any horizontal line gets a number. And two horizontal lines that line up with each other have the same number, right? The location of each relay contact controlled by a coil is identified by writing the line number on the contact's location to the right of L2 and adjacent to the coil symbol that controls the contact. Multiple contact line numbers are separated by commas. A normally closed contact location is underlined. These numbers are referred to as numerical cross-reference numbers. Y'all understand that? I did give you a copy of the U.S. Steel print, right? Okay, that's the one I thought. All lines must be either drawn horizontally or vertically. We have no curves. And all conductor connection points must be identified with a filled-in circle covering the connection joint. Y'all understand that one? So if we don't have a dot, we don't have a what? Connection. This rule was originally brought in because of the way we used to copy prints. And what would happen is you'd take a copy and you'd give out the original, and then you'd start making copies of copies. And after a while, the lines would actually disappear. But you could see where it came, and down here you could see a dot, and you would know that the line would actually connect there. So dots wouldn't disappear, but lines would eventually was. We don't have that problem now, and I guess I should have turned on my projector, but y'all got them at Regent. We don't have that problem now because these diagrams are kept on our computers, and we run as many originals as we want to. So everybody okay on those rules? Yes, no? You got any questions on them? Okay. And now, of course, these should match the truth table. Originally, when I gave it out, and I decided to do it this way because I didn't have enough room to put another row in there. For every row, for every contact you add, except for exclusive ORs, inclusive NORs, it doubles the number of these. So that means if I go to 3, then this over here would have to have 8 entries in the truth table. So these guys, remember, it's not 2. It says 2 or more. 2 or more. So to get ands, ors, nands, and nors, you can have 2 or more, right? You understand? We only draw 2 because it makes the truth table shorter. Now, exclusive ORs will always have what? 2. Controlled by the same two control devices. So here we did label A and B. These would be controlled by different devices. But in exclusive ORs and exclusive NORs, we always have the same device. So here we label them A, B, and AB. That makes sense? Okay. And these are the 5 logic circuits. These are the actual logic here. This is just a name given to a circuit that we use quite often. So exclusive ORs and exclusive NORs, what we're doing is we're trying to determine if the 2 inputs are the same or the 2 inputs are different. So an exclusive OR, we get a 0 if they're the same. We get a 1 or true, the output of the rung. So 1 means the output of the rung, which would be right here, would allow the signal to flow through to that point right there. Does that make sense? Okay. So exclusive OR, if they're the same, then the output would be false. If they're different, then the output would be true. For an exclusive NOR, if the inputs were the same, the output would be true. If they're different, the output would be false. Everybody okay on those? So what we do in exclusive OR and exclusive NOR, we're comparing 2 inputs to determine if they're the same or if they're what? If they're different. I think I told y'all about the manufacturing line over there when we was programming 2 switches that would switch the line between auto and manual. Well, it's 2 switches in 2 locations, And what I decided to do was make both of them be in auto or both of them be in what? Manual. And so this is what I used in the logic. Well, okay. Okay.